So thank you so much for your presentation, Mr. George. And Mr. Varun Kumar, over to you.
Yeah. Good evening, everybody. First, I'd like to thank Mission Energy and Achinji for relentlessly keep organizing these events, which have become the only platform for our industry, gasification industry. And then I'd like to thank Rahul, for summing up so nicely what we have been, both of us, KS and Dev Energy have been doing, and and we have been, I think, probably good marathon runners, pushing each other, over last 14, 15 years to be active. And this innovation world has been part of both our organizations, DNA. Keep finding new things, keep doing new things, keep challenging people. That's what we have been doing. And one bottom line before I start my presentation, I'd like to say is that when, like Dr. Saab, I was talking backstage, when there was no innovation in India on gasification, we have been trying to get the same from China. The Chinese have been 20 years ahead of us on this. We have similar amount of coal, we have similar energy needs, but we have been way behind in using coal for our energy needs. And now that government has started pushing, and which all the speakers have been since morning saying, so we are very happy. But since 2004, when we started till now, it's always been a fight to convert what is available in China into what is Indian circumstances. And that's what has been the DNA of innovation which we have been doing. So I'll just switch on my slides. Are the slides visible?
Yes, we can see your slides and we can hear you loud and clear. Please go ahead.
Yeah. So just a brief background of who we are. Uh, we have been working in the area of coal gasification as a technology EPC provider since 2004. And we have right now around 180 operating gasifier systems. All of them are fixed bed, air fed, and normal pressure. So why these 3 points are important is because when you have a gasifier which is at normal pressure, the capex of that equipment is very nominal. Then second point, when it is air fed, not oxygen fed, the whole combustion mechanisms and the dynamics within the gasifier are really controllable, and therefore the capex and refractories and the steel and the cooling mechanism, everything is at normal operatable pressures and quality. So therefore the capex for these plants have been very reasonable. And as Rahul had presented, that when you have a saving of 40% in a fuel, and for a rolling mill, typically if you are consuming a 5 crore rupees of fuel in a year, and a 40% saving gives them a 2.5 crore saving, then the capex has to be in that range to make it a logical investment. So most of the plants which we have done in India, the payback has been less than a year. Most of these plants have been in steel, ceramic, glass, and non-ferrous industry, and in partnership with our partners in China, Yishin. Now, the key to innovation is, there are two parts to innovation. Part one is that I bring something to the table, a technology, a solution. But there is another part, which Mr. V.R. Sharma was saying in every subsequent line, is the entrepreneur's role. The entrepreneur has to take the call to buy that technology, to take that risk, to invest. If they don't do it, then none of these first plants will come. Because once the first plant has come and the technology is proven, then the second is very easy, right? So today, why are we fighting with the indigenous technology development in the area of methanol, or even for converting the rice straw, which Mr. Sharma was saying, into anything usable for boilers, is because nobody's ready to put the first plant. So what we have tried to achieve from last uh, 15, 17 years we have been in this business is to come up with solutions and go to customers, go to willing clients, and present these solutions in form of doable risk-free ventures. And therefore we have been able to achieve first coal gas plant in iron ore pellet, first uh, coal gas plant in glass furnace, bone china. So many such firsts we have tried to achieve in the last decade. So, what is the core of the technology? The core of our technology is that it's a two-stage fixed bed updraft technology, wherein you treat the coal in two parts. So, why two parts? Because the energy of coal is locked in two components. One is the volatile matter, which are the hydrocarbons. The hydrocarbons lock their energy in form of unsaturated double, triple bonds hydrocarbons, which need to be taken out at a lower temperature if you want to avoid cracking and you want to take out their higher energy. So that is step one. And step two, then you need to convert the carbon into the gases of gasification, which are a combination of methane, carbon monoxide, and hydrogen through the reduction and gasification reactions. So what we do, our gasifier convert the coal in these two steps into two gas trains, one upstage, one downstage, with two different characteristics, which through this complete cooling and cleaning process, six stages, different stages of cleaning and cooling processes, we take out all the tar, dust, and we cool the gas to ambient temperature, like 45 degrees, and then we boost it, take the sulfur out, and make the gas usable for any industry. So the gas at this stage becomes clean enough to replace propane, natural gas. It becomes clean enough to be compressed and to be transported over large distances. We have a plant where we are running it over 200, 2.5 kilometers. Then in terms of cleanliness, we have a plant where we are running this gas on a bone china kiln, where the particulate matter, the tar and dust, is required to be less than 10. So uh, the gas outlet quality can be tailored to the customer requirement for all the thermal applications almost under the sun. Our Chinese partner have more than 45 industry experience. I in India have done around 8 different industries where these gasifiers are operating 100% successfully. Most of these systems are completely automated and synced with the user. So the furnace DCS automation system and the gasifier DCS automation system are synced, and both of them run parallelly and in sync with each other. So therefore, currently the systems are 100% reliable. They have an uptime of almost 1.5 years without shutdown. The reliability is such that most of our clients today do not have even backup fuel. So they have independent gasifiers. They don't even have any other fuel line in the system. So that is the level of reliability and comfort we have. So these are some of the projects descriptions which we have done. These are pellet plants, straight gate pellet plants. This is a glass unit we converted from the conventional fuel to coal gas. This is Jindal Steel and Power. Their Patratu, they have a rolling mill which has a 260 ton per hour furnace which is running on gasifier. Uh, these are some of the ceramic tile units which are running on our gasifiers. So in ceramic tile, the the temperature required in the kiln has to be maintained at plus minus 1 degree in every zone. So therefore, the system which you supply to these plants should be responsive enough to change its flow based on that modulation of the furnace for 1 degree. So therefore, these are very robust and reliable system for heat application. Now, I like to, at this stage, I'll carry on from where Rahul has left. That why, I mean, we have been successful. We have been doing so much business for last, 15 years. But still, what is the road ahead? What are the current challenges with these technologies? So, challenge one, they can use only sized coal. so 15 to 70 mm, which was readily available when the overall demand was less, and you could use the residual finer coals in DRI sponge kilns and the power plants. But currently, the dynamics of coal have changed, and the sized coal prices, if you want to size it, the prices are very high. And if you want to put up very large systems, then the amount of sized which you recover is very less. Second, because they have a large fixed bed, you need a particular hardness and you need a very high ash fusion temperature for these coals, for these gasifiers, which can be used in these coals. And then one module can generate, 10,000, around 10,000, 8 to 12,000 maximum gasifier NMQ per hour per gasifier. So if somebody wants, let's say, 200,000 nm cube of gas, so then you need to put up 25 systems, 20 plus 4 standby, which becomes a really sort of illogical setup. The carbon conversion is low. Both tar plus gas, the conversion maximum we have reached is 89%. But still, I mean, we are saying it's the best in the world, but still, as compared to the other technology platforms, this becomes 10% lower, right? So you are at 96% in CFB gasifiers. Because of nitrogen, there is a carryover when you are taking the gas, because 52% of nitrogen goes from the gasifier through the furnaces. So in case there are furnaces where they don't have the volume to take that nitrogen, then the gas calorific value has to be higher, nitrogen should not be there. So what is the solution? The solution moving forward is circulating fluidized bed. So what is a CFB gasifier? A CFB gasifier is basically a large diameter, a large height chamber where you are injecting pulverized coal, and the high pressure charge is making it float. And in the flotation process, all the carbon content in the coal is getting converted into CO and H2 if you're using water, and that gas combination is then taken out through a basic cleaning and cooling mechanism through waste heat boiler, then cyclones, bag filter, indirect cooler, to make it into a usable gas which can be used for thermal application. Now, when you take this technology and operate it at normal pressure, atmospheric pressure, you're not operating it at very high pressures like 10 bar or 20 bar, which our European gasifier technology license providers are doing, then yes, the rate of reaction is low, but the cost of equipment, the capex, is very low also. Second, when you are using air as the charge, then the reaction temperatures are very low. Therefore, the refractory lining inside the gasifiers are normal, and the whole system operates at a very large range of flexibility. You don't need to operate the gasifier at a very tight range. So therefore, this becomes a very doable solution. In China, our partners have supplied at three places where alumina calciners are running on gas generated from these type of gasifiers, complete thermal application, air-fed gasifiers, and they have replaced 100% furnace oil. In India, all the calciners today, all the major brands, Hindalco, Vedanta, everybody is running calciners on furnace oil, and it's a large consumer. The amounts are enormous. Amounts of furnace oil they are using are enormous. Even pellet plants, the large pellet plants, the 4 million ton, 6 million ton pellet plants are running on furnace oil. So this is the ideal solution for them. This is one of the photographs I've just put in to show what type of setup this runs. So this is the main body of the gasifier, and then the heat exchanger and indirect cooler. So this is the train. So why is CFB the future? One, it can use coal fines. Second, it's an open source technology. There is no license fee. any, as you know, what is famous about China is that there is no charge for drawing, right? So when you do business with China, it's the charge only for the equipment. So once a technology has been tried and tested in China, then the equipment is available without any exorbitant premiums over the cost of construction of the equipment. It is atmospheric pressure, I've already explained. Now, because your operating temperature are medium, so therefore the possibility of clinkering of ash, possibility of fusion of ash is not there. Then medium level of gas cleaning, you don't need the large rectisol and other types of gas cleaning systems, which are even more expensive than the gasifier train. So you are using the basic rudimentary systems to clean the gas. The single gasifier is available up to 40,000, 60,000 meter cube. Also, a new model has come up, 8 meter. So therefore, if there is a large user, then three modules can supply them the required gas. And the capex per gasifier is much lower than any competing technologies for such thermal applications. Before I go to this slide, I'd like to add one point here, which was presented by Rahul, that yes, CFB gasifiers, there is an issue with high ash. Now, my understanding of last 18 years in this business, high ash has problem in all the gasifiers. So rather than fighting with the problem, I have a more practical solution. You see, lignite and Indonesian coal, high VM, low fusion temperature, high moisture coal is readily available at a comfortable cost. If you are blending these two coals, then you get a coal which is absolutely desirable for these gasifiers. The high ash coal is a problem in any type of gasifier. Why? Because in the fixed bed, it will create clinkering. In the CFB gasifier, it will not float because of its density and its tendency to fall. And its entrail bed, it will create blockages in the entrailment of the flow. So in any case, it is a problem. Unless somebody puts a gun to my head and says you have to put this gasifier, I'll not use that high ash. I'll rather come up with a solution of blending. And uh, most most intelligent operators across the world have been using coal blending as the right solution to gasification problems. Most of that data is not in public domain, because even for JSPL, the blending techniques and the systems they have used, there are many people in the audience who have been operating those plants. I don't know whether they'll share it or not, but blending is the solution, right, for all types of gasifier, fixed bed, CFB, entrail bed, all types of gasifier. One last final slide of innovation, which I have an idea. I have been trying to work this out with the stakeholders, both from the DRI clean side and the gasifier side, and it's a work in progress. So I just wanted to throw it open to the audience and the team so that industry can pick it up and maybe we can come up with some solution. So the idea is that you have a CFB gasifier or any type of gasifier wherein we use coal and generate a gas. Now this gas, if generated at normal pressure and under normal gasifiers, will have low hydrogen and more CO. Now the DRI clean, the vertical clean, needs more hydrogen. So the idea is to compensate that through green hydrogen or gray hydrogen through a thermal power plant or a solar plant feeding a PEM hydrogen generator, and you take a hydrogen and then you combine them to create a gas strain and a ratio which is suitable for the feed of the DRI clean. So therefore, in this system, you are only putting coal for thermal energy for power plant, and you are putting coal, and the oxygen generated through the PEM generators can also be used as a feedstock for the gasifier. And the hot DRI can be fed into EF, which is already happening in the JSPL Angul plant and also in JSW PEN plant. So, and this can be used to generate steel. This whole process will take us away from met coke blast furnace route and will help us in this journey to self-reliant coal-based steel production. So that's my final submission of idea. Thank you. Thank you.
Thank you, Mr. Varun Kumar, for the presentation. And we are getting some questions as well. My suggestion is that at the end of this session, we can request some of the speakers who have questions to come on stage and ask their questions. I think Mr. Tiwari is keen to ask questions. Mr. Tiwari, I request you to hold on because we have one more speaker. And once you've heard him, we will start this discussion. So please welcome Dr. Prakash T. Chavan, Senior Principal Scientist, CSIR, CIMFS. Now we have a few questions. So I'm going to hand over the mic to Mr. Shakti Kumar Pandey, who has the first question that he wants to pose.
Yeah. Am I audible?
Yes, sir, you can turn on your camera as well. We can hear you
Okay.
clearly.
Okay, but I want to turn up the camera also.
Yeah, you
Okay,
can
fine.
turn it
Yeah,
on,
yeah,
sir.
yeah, yeah. Yeah, this question goes to Mr. Varun Kumar ji. It was definitely a very good presentation. Mr. Varun Kumar, we have got as we know, the time, temperature, turbulence, and active sites. These are the four factors that determine the performance of a gasifier for the different reasons. In case of the entrained and the fluidized-based gasifier, which one gives the more reactive sites for the reaction to uh, gas?
So, sir, I would like to answer your question slightly differently.
Right.
You see, as I said in the presentation, my understanding is all the gasifiers are good gasifiers. I think Dr. Prakash can also say all are good. They are conversion equipments. They can convert a solid fuel into a gaseous fuel. Now, the problem with this statement is that we should know what this conversion equipment can convert. What is the input that it can take? For example, as I explained that fixed bed systems, updraft systems can take high ash fusion temperature hard coals. As the CFB gasifiers are more suitable for low ash, light, low fusion temperature coals. Entrailed bed are suitable for coals which ash can flow. Now the problem is that for finding the right raw material for an entrail bed, you need to do the complete analysis that how will the ash behave when subjected to such pressures and such temperatures. So there is no answer which is good, which is bad. Answer is which is suitable. You have to find out and analyze for your raw material, whatever raw material you have, what is the most suitable technology.
Right, because that's our ash content is in order from 35% generally. As against,
Sir, I don't know. In the industry, most people who have never dealt with coal, everybody comes up with this statement. Our coal, India has all types of coal, starting from coals with very low ash to starting to coals of very high ash. Now we need to find out which coals can be gasified, and I have been talking to coal ministry and most of the representatives that why are we trying to do something which is not doable? Why don't we try and find coals and collieries which have medium ash, 25 to 35 ash and medium VM, and try and gasify that?
we
Why are
take
we rewriting the whole physics and chemistry of the gasification industry?
right, right. Let us forget about the Raniganj coal and the Rewa coal. If you got the other type of
I'm
coal
saying,
there.
I'm saying, let's leave the very good coals also, and let's leave the very bad coals also in terms of ash content and CV, and let's focus on the middle range.
Right,
Even
right. Let's
that,
put this way. Let's
even
put
that
this way.
coal we have more than 1 billion. Okay, even that coal we can gasify, and we are. I mean, I have no words to say what we are doing. We are just discussing and debating, and nobody says that okay, this is the coal, this is available, this is the most suitable. These two collieries are reserved or specified for coal gasification. Right? That's not happening in our country.
Let us come to the bituminous coal mostly found in India. So, because I am asking these questions that the Talcher plant, fertilizer plant, failed this gasification on account of the technology mismatch. And the main reason behind the failure was reported to be the high ash content. China has developed, which has only 25% ash content. We have about 35%, as it was reported to be. So, in this context, my question was that for the bituminous coal found in India, which contains, if I am right, around 35%, which type of the gasifier is the most suitable? That is my question.
Sir, for Indian coals, up to 35% ash, CFB, according to me, is a better technology. But I will caveat my statement with the fact that different collieries and different regions within CCL umbrella have different characteristics of density and ash fusion temperature and caking index and various other components like plasticity of the coal, which need to be measured to say the appropriation of the coal for a particular technology.
Okay, thank you, Mr. Kumar. Thank you very much.
Thank you. Thank you.
So particularly for culture coal, government has already planned a culture fertilizer project where they have planned utilization of high ash coal along with pet coke. So blends will be prepared to bring down the ash content below acceptable limit, and uh, it is going to be gasified inside the entrance flue gasifier also. Apart from that, already GSPL has tried. I think if Tiwari sir is there, he can comment more. But they have also tried for MCL coal. And definitely, blends of low ash, high ash coal will work inside the entrance flue gasifier as well as fixed bed gasifier. And in the fluidized bed gasifier, it can be gasified without any blending also, without any blending or washing. But only thing is readily available or proven technologies are not available under fluidized bed. But we have tested in our fluidized bed facilities up to 48% ash containing coal. So it can be gasified without any operational issues in fluidized bed gasifier at least.
Yeah. Just to add to what Dr. Saab has said, uh, the plant which I mentioned in China running for the alumina calciner, the coal which they are using is bituminous, not anthracite, and it has around 27-28% ash. So it is possible, like Dr. Prakash is saying, it is possible that Indian coal up to 35% ash can easily be gasified in the CFB gasifiers, provided they are not detrimental to other aspects at that temperature. Right.
I'd like to add here something a little bit to the ash content related to the coal part. See, what our experience has been for CFBC gasifiers and the entrained gasifiers. Entrained is basically introduced, this technology is introduced to utilize high ash coal, which CFBC gasifier is, as of now, not capable to utilize. It's absolutely clear. Our partners have tried using high ash coal. As Varunji said, up to 25% ash is possible for CFBC gasifiers. But beyond that, you need to change your technology to entrained gasification. Entrained gasification can take ash content up to 40-45%, which is a beautiful technology for India. And the best part about this entrained gasification is that the calorific value of the gas is double that of normal gasifiers. Like if we talk about fixed bed gasification, we talk about CFBC. Entrained gasification has CV around 2600 kcal. This is because you're able to use oxygen 99.99% in these entrained gasifiers.
All right. We have Mr. A.N. Tiwari also with us. Mr. Tiwari, please go ahead and ask your question. You can start your
Yeah,
camera as well.
thank you. First of all, I don't agree, Rahul, that in train bed calorific value is double than of fixed bed gasifier. How can it be?
So there is no nitrogen in the gas. I'll share the gas composition with you.
No gasifier is having nitrogen, sir, other than the gasifiers running on atmospheric and producer gas plants. So
So
let us not discuss that thing, because if you see the calorific value of entrained bed, they will CO and hydrogen both will be roughly 85. So they are 26-2700 is the calorific value there, and you will have the same value in the fixed bed also, because fixed bed have methane of almost 13%, so which increases the calorific value. So if you
so
talk the
I
calorific value is high in the fixed bed. Anyway, yeah, please.
I am talking about gasification, not before the steam shift, where you increase the hydrogen.
I'm not talking steam shift, sir. I'm talking gasifier. I'm not talking steam shift. I'm talking gasifier outlet, raw gas.
Raw gas calorific value, you said how much was that?
It's around 2700, 2800.
That is what I'm saying. That's exactly what I said. In train flow
The,
gasifier, we can
the
get.
fixed bed also, the fixed bed also have that.
So you must be doing some oxygen enrichment in that, sir.
Oxygen enrichment, how can you do the oxygen enrichment? There is nothing like oxygen enrichment. Gasifiers are partial oxidation. You cannot increase the oxygen. If oxygen goes in
Sir,
the gas, it will
basically,
explode.
100% oxygen. Their
It's
gasifier in
a,
Nakul is using.
gasifiers are oxygen only, 100% oxygen only.
Obviously,
There is
in
a
that case, then you can get that CV, no, sir? Because
That's what. So when
your
you told the
gasifying
fixed bed will,
your gasifying agent is oxygen in place of air. So there
so
is no
Rahul, that's what.
nitrogen in your final product.
Don't, sir, please don't compare producer gas with the syngas. We are talking when the syngas producer plant will never operate with the oxygens. So let us not confuse with those things. Regarding blending of the coal, when you are blending the coal, you are bringing the ash down only theoretically. Practically, it is not possible because it's not a homogeneous mixture. If you are using all other gasifiers, they will be two different material, and gasifier behavior will be totally different. In trend bed, it may not have that much impact because it's you are using almost 200 micron, and in 15 seconds it will burn and go. So in trend bed, it will not have that much impact, but fluidized bed and fixed bed blending is not the solution. JSPL was blending because we were using imported coal for the high FC, not for the purpose of ash reduction. The
Right, Mr.
coal
Tiwari,
imported.
you have any specific question to one of the
Other
speakers?
specific question, Varun, you were telling that we can mix the lignite. Lignite is a solution. Lignite has almost 50% of the moisture, and that much moisture goes in the gasifier means that much energy is consumed. So your specific consumption will increase. So how you say that lignite is a solution for reducing the ash? Because you are putting lot of water and water has to go as a water vapor. Lot of energy is consumed, and for that coal has to burn in that.
Yes, Tiwariji, but when you talk to Navy Lignite, they are sitting on those deposits doing nothing. Okay, so whatever in my presentation I have presented, and I am a businessman, I am not a scientist. So whenever I say something, I have a commercial angle to the same suggestion always linked behind it. So
No, that's fine, sir.
when I say we can use lignite, there is a commercial aspect of lignite cost being zero. Right? Why zero? Because we are not able to use it. For example, in Rajasthan, there is no practical industrial use to whatever deposits we have. So, when we are saying there is the economic carryover, yes, I understand. I cannot deny any technical point which you are raising. But please add the commercial side to whatever I'm saying. You can get much better value even with wastage of resources of trying evaporating water and getting it back. I've done the maths. We can share.
Yeah, that's okay. All the maths on the papers are working good.
sir, for
Practically,
Navy
it is,
Lignite, NLC has already published expression of interest, and they have plans for gasification based methanol.
no, everybody is planning. Everybody is planning. Who will come? Question is that last 16 years I'm hearing that.
And
So I'll
lignite
contact
can
you.
be lignite.
And
Since it is
Varun,
lowest.
Varun,
Tiwariji,
yeah,
I'm also listening this for a very long time, but probably from last 3 or 4 years, I am happy that developments are happening in India and there is some policy making is happening. Am I right, Varunji?
no,
At least we
you
are
are.
moving. At least we have a forum. I really appreciate that. At least we have been called by Ministry of Coal, Ministry of Steel, Niti Aayog. At least me, Rahul. We have been talking to people, and at least somebody is listening.
Yeah.
So yeah. So Tiwari is saying yes, frustration is there in the industry, but there is a positive side also. So life is like this. I think we have to be.
Right.
Let's be